Hello students, welcome to another video. Today we will be solving Pure Maths Paper 1 from October-November 2017, variant 13. Question number 1, it says, an arithmetic progression has first term -12 and common difference 6. The sum of the first n terms exceeds 3000. Calculate the least possible value of n. So the first term is -12 and the common difference is 6. And it's also given that the sum of the first n terms exceeds 3000. So sum of n terms, we can use the formula n over 2 within brackets 2a plus n minus 1 times d. So we know the first term. The first term is -12 plus n minus 1 and the common difference is 6. Must be greater than 3000. So if we cross multiply, 2 and 3000 will become 6000. And this will become -24 plus 6n minus 6. If we simplify it further, we get -30 plus 6n within brackets. And by multiplying it with n, we get 6n square minus 30n minus 6000 greater than 0. We can simplify this equation further by dividing both sides with 6. And we get n square minus 5n minus 1000 greater than 0. Now we can solve this with the help of quadratic formula. So this will be n is equal to minus b plus minus root over b square minus 4ac over 2a. So that will be minus 5 plus minus square root of -5 whole square minus 4, a is 1 and c is -1000. So that will give us n is equals to 34.22 and n is -29.22. But we know that n is an integer and it has to be greater than 0. So that means n can be 35. That is because the 34th term will not be sufficient enough to exceed 3000. The 34th term will not be sufficient enough. That means 35th term is the required term which exceeds 3000. Question number 2. Find the set of values of a for which the curve y equals to -2 over x and the straight line y equals to ax plus 3a meet at two distinct points. Since they will be meeting at two distinct points, let's equate these two equations. So that will be y is equals to y. That means -2 over x is equals to ax plus 3a. Cross multiplying x with this equation, we get -2 is equals to ax square plus 3ax. That means ax square plus 3ax plus 2 is equals to 0. Now, since we need to find the set of values of a for which they meet at two distinct points, that means the discriminant b square minus 4ac must be greater than 0. So for this equation, our a will be this a, b is 3a and c is +2. So b square minus 4ac will be 3a whole square minus 4a times 2, which gives us 9a square minus 8a greater than 0. If we take a common, we get 9a minus 8 within brackets. That means a is equal to 0 and a will be 8 over 9. Since these are the two values and we have a positive quadratic equation, that means in order to be, the discriminant be greater than 0, a must be less than 0 and a must be greater than 8 over 9. Question number 3. The first part says, find the term independent of x in the expansion of 2 over x minus 3x to the power 6. So to expand this equation, it must be 6cr 2 over x to the power 6 minus r minus 3x to the power r. Now, independent term of x means x to the power 0. So we need to find the term which is independent of x. So let's first isolate the x terms from this equation. So this will be, if we just focus on the x terms, this will be x to the power negative 6 minus r times x to the power r. So we are just focusing on the x values, and we are trying to figure out what will be the value of r with which we can find the independent term of x. So with the help of the product rule, we get minus 6 plus r. So this will be minus 6 minus minus will become plus. So it will be plus r, and multiplying means we need to add the power. So that will be plus r. Simplifying it, we get 2r minus 6. So with the help of equality rule, we can say that 2r minus 6 is equals to 0. Therefore, r is equals to 3. That means when r is 3, we will be getting the independent term of x. So let's substitute the value 3 into this equation, and we get 6c3 2 over x to the power 3 minus 3x to the power 3. 6c3 will give us 20. 2 over x to the power 3 will give us 8 over x cube, and this will become negative 27x cube. Simplifying this, we get negative 4320 because x cube and x cube will cancel out. So the term independent of x is negative 4320. In the second part of the question, it says find the value of a for which there is no term independent of x in the expansion of this equation. So in order to proceed with this, first we need to think a few things, and that is, when 1 will get multiplied with the term independent of x from the expansion of this, we will get a term which is independent of x. Also, when ax square will get multiplied with one of the term which will have x square in the denominator, then both of the x squares will cancel out and we will get another term which is independent of x. So that means we first must find out what is the what will be the r value for which we can get x to the power negative 2, which is basically having x square in the denominator from this term. So let's first find that out. Again, the expansion will be 6cr 2 over x to the power 6 minus r minus 3x to the power r. Let's again isolate the x terms, and that will give us x to the power minus within bracket 6 minus r times x to the power r, and we want it to be x to the power minus 2. So since there is a multiplication, that means it will be minus 6 plus r is equal to x to the power negative 2. So that means x to the power 2r minus 6 is equals to x to the power negative 2. So 2r minus 6 is negative 2, therefore r will be 2. Now let's substitute this value of r into this equation. So that will be 6c2 2 over x to the power 4 and minus 3x whole square. 6c2 will give us 15, and 2 over x to the power 4 will give us 16 over x to the power 4 times minus 3x whole square will be 9x square. Simplifying this, we get 2160 x to the power negative 2. Now I hope you are getting the idea that if ax square gets multiplied with this, there will be another term which is independent of x. So what we can do now is simply multiply the coefficient of x square, which is a, and the coefficient of x to the power minus 2, which is 2160, and we should be getting 4320, because this is already so this value, we found this value with the help of the first part of the question, where we got negative 4320. That means if we have another term which will be positive 4320, then for the whole expansion of this equation, the negative 4320 and the positive 4320 will cancel out, and we will have no term independent of x in the expansion of this. So a times 2160 gives us 4320. This is what we need. So for that, a has to be 2. So this is the explanation. When 1 is getting multiplied with the negative 4320, we get negative 4320. And when the value of a will be 2, and if we multiply 2 with 2160, we will be getting positive 4320. So these two constants will cancel out, and we will be left with no term independent of x in the expansion of this. And this can only happen if the value of a is 2. Question number 4. The function f is such that f of x is equals to 2x minus 1 to the power 3 by 2 minus 6x for half x lies between half and k, where k is a constant. Find the largest value of k for which f is a decreasing function. So f of x is 2x minus 1 to the power 3 by 2 minus 6x. Let's differentiate this equation. And we get 3 over 2, 2x minus 1 to the power half times 2. First, we multiplied the power with 1 over here, and we took away 1 from the power and we got half, and then we differentiated the elements within the brackets and we got 2. And differentiating 6's will give us 6. We know that the stationary value occurs when the differentiation of the function is equals to 0. So that means, simplifying this equation, we get 3 times 2x minus 1 to the power half minus 6 is equals to 0. That means 3 times 2x minus 1 to the power half is equals to 6. Therefore, 2x minus 1 to the power half will be equals to 2. So 2x minus 1 is equals to 4. Therefore, x will be equal to 5 over 2. So the largest value of k is 5 over 2. Question number 5. Show that the equation cos theta plus 4 over sin theta plus 1 plus 5 sin theta minus 5 is equals to 0. This can be expressed as 5 cos square theta minus 4 equals to 0. We can clearly see that there is no sin theta or sin square theta in this expression. So we need to keep this in mind. Now let's focus on the solution. So cos theta plus 4, if we do LCM, that means sin theta plus 1 will be in the denominator and cos theta plus 4 will remain the way it is, and we need to multiply sin theta plus 1 with 5 sin theta, which gives us 5 sin square theta plus 5 sin theta. And also we need to multiply negative 5 with 5 sin theta plus 1, which will give us negative 5 sin theta and negative 5. Simplifying this, we can see there is a positive 5 sin theta and negative 5 sin theta. They can cancel out, and we are left with cos theta plus 4 plus 5 sin square theta minus 5. By cross multiplying sin theta plus 1 and 0, it becomes 0. So simplifying this further, we get cos theta minus 1 plus 5, and we can manipulate sin square theta as 1 minus cos square theta. So this becomes cos theta minus 1 plus 5. 5 times negative cos square theta is negative 5 cos square theta. So we can rewrite this equation as 5 minus 5 cos square theta plus 4 equals to 0. And then we can multiply both sides of the equation with negative 1, and we get 5 cos square theta minus 4 equals to 0. And this is the expression that they are looking for. The second part of the question says, hence solve the equation cos theta plus 4 over sin theta plus 1 plus 5 sin theta minus 5 equals to 0 for this limit. We have already expressed this equation in the previous part, which is 5 cos square theta minus 4 equals to 0. We can clearly see that this is a quadratic equation. To make it simple, we can consider x to be cos theta, and we can write it as 5x square minus x minus 4 equals to 0. So that will be, if we do middle term break, we get 5x square minus 5x plus 4x minus 4 equals to 0. if we take 5x common, we get x minus 1, and if we take 4 common, we get again x minus 1. So the factors will be 5x plus 4 and x minus 1 equals to 0. So basically, x is negative 4 over 5 and x is 1, which means cos theta is negative 4 over 5 and cos theta is positive 1. Now let's find the basic angle. The basic angle alpha is cos inverse of 4 over 5, and the basic angle of this value will be cos inverse of 1. So basic angle is 36.87, and for this the basic angle is 0. Now let's check the limits again. So theta lies between 0 and 360. And for the first part we have a negative cos, that means it will lie in the second and third quadrant. And positive cos lies in the first and fourth quadrant. So that means our theta will be 180 minus the basic angle, which gives us 143.13, and it will also be 180 plus the basic angle, which will give us 216.87. And for the second part, our basic angle will be our actual angle. Also, for the fourth quadrant, it will be 360 minus 0, which will give us 360. So theta must be 0 and 143.1, 216.9 and 360. Question number 6. The functions f and g are defined by f of x is equals to 2 over x square minus 1 for x is less than minus 1, and g of x is x squared plus 1 for x is greater than 0. For the first part of the question, we need to find the expression for f inverse of x. F of x is 2 over x square minus 1. Let's consider that y is equals to f of x. So y must be 2 over x square minus 1. Now let's make x square minus 1 the subject of the equation. That will give us 2 over y. So x square is equal to 2 over y plus 1. That means x must be equal to plus minus square root of 2 over y plus 1. F inverse of y is x. Therefore, f inverse of y must be plus minus square root of 2 over y plus 1. So f inverse of x must be plus minus square root of 2 over x plus 1. Since x is less than minus 1, therefore f inverse of x will be just square root of negative square root of 2 over y plus 1. The second part of the question says solve the equation gf of x equals to 5. F of x is 2 over x square minus 1 and g of x is x square plus 1. We are given that gf of x is equals to 5. That means first we need to substitute this equation into g of x, which will be equal to 5. So that means 2 over x square minus 1 whole square plus 1 is equals to 5. That gives us 2 square is 4 and x square minus 1 whole square plus 1 is equals to 5. Then we have 4 plus x square minus 1 whole square equals 5 within brackets x square minus 1 whole square. So what we did here, I cross multiplied x square minus 1 whole square with 5, but since there was no x square minus 1 whole square in the denominator of 1, I had to multiply this with 1 first and then cross multiply 5 with x square minus 1 whole square. So that gives us this, and simplifying this we get 4 is equals to 5x square minus 1 whole square minus x square minus 1 whole square. Or we can write it as 4 is equals to 4x square minus 1 whole square. We can then divide both sides by 4 and we get 1 is equals to x square minus 1 whole square. By square rooting both sides we get x square minus 1 is equals to positive 1. Therefore x square will be 2. So x will be plus minus square root of 2. And since the domain of f of x was x is less than minus 1, therefore x will be equal to negative square root of 2, and that will be the final answer. Question number 7. The diagram shows a rectangle ABCD in which AB is 5 units and BC is 3 units. Point P lies on DC. So this point P lies on the line DC, and AP is an arc. So AP is an arc of a circle with center B, and this is the center for the arc. Point Q lies on DC. So this point lies on DC, and AQ is an arc of a circle with center D. So this is another arc, and the center for this arc is the point D. So for the first part of the question, it says show that angle ABP. So this angle ABP is equal to 0.6435 radians corrected to 4 decimal places. So since ABP is a sector that and B is the center, that means AB and PB are the radius. So if this is 5, this should also be 5. Then in triangle BPC, the triangle BPC, cos PBC is equals to 3 over 5. So cos PBC, this angle, is adjacent by hypotenuse. So this is 3 and this is 5. So that gives us PBC is cos inverse of 0.6 because 3 over 5 is 0.6. So PBC will be, angle PBC will be 0.9273. So we managed to found angle PBC, which is this angle. So the required angle is ABP. This is what we need to find. Since this is a right angle, what we can do, right angle is pi by 2 in radians. So we can take away the angle PBC from right angle and we will be left with the angle ABP. ABP must be pi by 2 minus 0.9273, which is 0.6435 radians. In the second part of the question, we need to calculate the areas of the sectors BAP and DAQ. So let's look into the sectors first, BAP and DAQ. So we need to find this sector and DAQ. So with the help of the formula for the sector, which is half r squared theta when theta is in radians, so area of sector BAP will be half r square theta. We have just shown that angle ABP is 0.6435 and the radius for this sector is 5. So it will be half 5 square 0.6435, which gives us 8.04. And for the area of the sector DAQ, we have the radius as, so for the sector DAQ, DA is the radius and DQ is also radius. DA is equal to 3 because this whole thing is a rectangle. So it will be half 3 squared times pi by 2. The theta is pi by 2. So as you can see, the angle of this sector is pi by 2. So that gives us 9 pi by 4, which is the exact value, and in decimals it will be 7.07. For part 3, we need to calculate the area of the shaded region. So in order to solve this, what we can do, we can draw a few extra lines and figure out the solution. So I have already explained that if this is 5, this is 5. And if this is 3, because of the rectangle, this will also be 3. Now, let's focus on the triangle PBC, which is this right angle triangle. So PC, with the help of Pythagoras, what we can do, PC is equals to square root of 5 square minus 3 square, and that gives us PC is equals to 4. DC is equals to 5 and DQ is equals to 3. So this whole thing is 5 and DQ is 3 because it's the radius of the sector DAQ. So if this is 3, this whole thing is 3 DQ. That means QC is 2. this remaining bit must be 2. Therefore, PQ must be PC minus QC. So PC, which is this, minus QC. So therefore, PQ will be, we found that PC is 4 and QC is 2. Therefore, PQ is also 2. So area of the minor segment AP. Let's find the area of the minor segment AP. So that gives us half r square theta minus sine theta. So the theta is 0.6435 minus sine 0.6435, and that gives us 0.5438. And let's also find the area of the minor segment AQ. Let's find this region AQ, the minor segment. So that will be half, the radius is 3 square, times theta minus sine theta, where theta is 90 sine pi by 2. And that will give us 2.5686. It's better to have our answers, if it's in decimals, at least to 4 decimal places, unless we reach our final answer, so that we can avoid accuracy error. Now let's find the area of the triangle APQ, this triangle. So we know that we can use the formula half times base times height to find the area of the triangle APQ. So that will be half times base is 2, and the height of this triangle, the height of the vertical height of the triangle is 3. So the shaded area must be the two segments, the two minor segments, and the area of the triangle, which will be 0.5438 plus 3 plus 2.5686, and that gives us 6.11 to 3 significant figures. Question number 8. The diagram shows parts of the graphs y equals to 3 minus 2x and y equals to 4 minus 3 root x intersecting at points A and B. So these are the 2 points where these two equations are intersecting. We need to find by calculation the x coordinates of A and B, just the x coordinates. So these are the two equations. So that means when they're intersecting, they both share the same coordinates. So we can say y is equals to y. That means 3 minus 2x is equals to 4 minus 3 root x. Simplifying this further, we can say 3 root x minus 2x is equals to 4 minus 3. And that will give us 3 root x minus 2x is equals to 1. Or we can say minus 2x plus 3 root x minus 1 is equals to 0. By multiplying with negative 1 on both sides of the equation, we can say 2x minus 3 root x plus 1 is equals to 0. Now this can be a little tricky, but the more you solve, the more you know, and we can clearly then see that we can form a quadratic equation with the help of this. And how we can do that is by letting a is equals to root x. So if a is root x, then I can say that 2x must be then 2a square, because if you square root x, you get just x. So this becomes 2a square, and we have already considered that a is root x. That means this will become 3a plus 1 is equals to 0. So this is easier to solve rather than solving it this way. So this becomes 2a square minus 2a minus a plus 1 is equals to 0. By taking 2a common, we get a minus 1, and then again minus 1, and we get a minus 1. So that means we have 2a minus 1 and a minus 1 as the factors of the equation. So that means a is half and a is 1, which means x is 1 by 4, because if a is half, that means square root of x is half. So x will be, to find x, we need to square this. By squaring root x, we get x, and by squaring 1 by 2, we get 1 by 4. Also, root x is 1. So by squaring root x, we get x, and by squaring 1, we get 1. So the x coordinate of A must be 1 by 4, and the x coordinate of B must be 1. The reason is A is before the point B. So the x value of A must be smaller than the x value of B. In the second part of the question, we are asked to find, showing all necessary working, the area of the shaded region. So for this, we have already found the x coordinates, and that will act as limits of integration. So those are 1 and 0.25. So in order to find the area of the shaded region, what we plan to do is we need to find the area below the linear equation, and we need to take away the area below the equation of the curve. So that will be so to find the required area, we need to take away the area under the curve from the area under the line. So 3 minus 2x minus 4 minus 3 root x. If we simplify this equation further, we get 3 minus 2x minus 4 minus minus plus 3 root x, and the limits still remains 1 and 0.25. So again simplifying this, we get 3 root x minus 2x minus 1. Then if we integrate, we get square root of x means x to the power half. So half plus 1 is 3 by 2, and when you divide 3 by 3 by 2, you get just 2, and the power becomes x to the power 3 by 2. So if you integrate 2x, you will get x squared, and if you integrate 1, you get x. So now we can substitute these two limits into the equation, and we will get 0 minus minus 1 over 16, which is 0.0625. Question number 9 is not in the syllabus at the moment. Question number 10. The curve has equation y equals to f of x, and it is given that f prime x is equal to ax squared plus bx, where a and b are positive constants. Find, in terms of a and b, the non-zero value of x for which the curve has a stationary point, and determine, showing all necessary working, the nature of this stationary point. So f prime x is equals to ax squared plus bx, and we know that at stationary point it will be 0. So that means ax squared plus bx is equals to 0. If we take x common, then we get ax plus b equals to 0. So therefore x is either 0 or x is negative b over a. But since the question states that it's a non-zero value, that means x can only be negative b over a. So that is the first part of the answer. Now for the second part, we need to determine the nature of the stationary point. So we can simply then substitute this value of x into the double differentiated value of f of x. So if you double differentiate this equation, you get 2ax plus b. Then substituting x equals to minus b by a, we get 2a within brackets minus b by a plus b. Simplifying this, we get negative 2b plus b. And the answer would be minus b. So since we can see in the question, it says that a and b itself are positive constants. So negative b must be a negative constant, and that determines that the point is a maximum point. In the second part of the question, it says that it's given that the curve has a stationary point at negative 2, negative 3, and the gradient of the curve at x equals to 1 is 9. We need to find f of x. So for the stationary point, that means f prime of minus 2 must be equal to 0, because the stationary point occurs at x equals to minus 2. We can substitute this value into this equation, and we get a minus 2 whole square plus b minus 2 equals to 0. So that will give us 4a minus 2b is equals to 0. So 2a minus b is equals to 0. Therefore, b is equals to 2a. So let that be equation 1. And we can also see that the gradient will be 9 when x is 1. That means f prime of 1 will give you 9. Again, we substitute x equals to 1 into this equation and we get a1 whole square plus b times 1 is equals to 9. Therefore, a plus b is equals to 9. Let us call this equation to be equation number 2. So using both of this equation, we can get a plus 2a is equals to 9. So I have substituted b with 2a. So I got a plus 2a is equals to 9. Therefore, 3a is equals to 9. So a is equals to 3. So when a is equals to 3, b must be 2 times 3. So b will be 6. So that means f prime x will be 3x square plus 6x. So f of x must be found with the help of integration. So integrating 3x square gives us x cube, and if we integrate 6x we get 3x square, and then we have a constant. So now we need to find the constant. We are already provided with the coordinate which lies on the curve. The point -2 and -3 satisfy the equation of the curve because it lies on the curve. So we can use that into this equation to find c. So f of -2 is equals to -3. So -2 whole cube plus 3 minus 2 whole square plus c is equals to 3. -3. So -8 plus 12 plus c is -3. So c must be -7. So the required equation must be f of x is equals to x cube plus 3x square and -7. Question number 11. The diagram shows the curve y is equals to x minus 1 to the power half and points a, which is 1, 0, and b, which is 5, 2, lying on the curve. Find the equation of the line AB, giving your answer in the form y is equals to mx plus c. So in order to find the equation of the line AB, we can simply use these two coordinates, and the formula we are using here is y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. So that gives us y minus 0 over 2 minus 0 and x minus 1 over 5 minus 1. Then we get, if we cross multiply, 5 minus 1 is 4. So 4 times y will be 4y, and this will be 2x minus 2. So let's make y the subject, and we will get y is equals to 2x minus 2 over 4. But they have asked us to express this in this format. So that means this will become y is equals to half of x minus half. In the second part of the question, it says that find, showing all necessary working, the equation of the tangent to the curve which is parallel to AB. So that means if we look into the diagram, they're asking for the line which is parallel to AB but must be a tangent to the curve. So it will lie somewhere over here. So since they are parallel, that means they will have the same gradient. So let's first find the gradient. We are provided with the equation of the curve. So if we differentiate the equation of the curve, we get half x minus 1 to the power half minus 1 will be -half times the differentiation of x is just 1. So simplifying this, we get 1 over 2 root over x minus 1. So from the last part of the question, we have already found that the gradient of the line AB was half. That means the tangent, which will be parallel to the line AB, must also have the same gradient. Therefore, 1 over 2 root over x minus 1 should be equal to half. So root over x minus 1 is half. If I square both sides, I get x minus 1 is 1. Therefore, x is equals to 2. Now, when I substitute this value of x, which is 2, into the equation of the curve, I get y is equals to 2 minus 1 to the power half, and that will be y is equals to 1. So the equation of the tangent must be y minus y1 equals mx minus x1. So the value of y1 is 1 and the value of x1 is 2 and the gradient is half, the same gradient as AB. So simplifying this, we get y is equals to half of x. In the third part of the question, we need to find the perpendicular distance between the line AB and the tangent parallel to AB. Give me your answer correct to 2 decimal places. So this is the diagram that we are talking about. So this was the line AB and this is the line which is y equals to half x parallel to the line AB having the same gradient. And we have found so far that the point at which the tangent occurs is 2, 1, and we need to find the perpendicular distance between this line and this line. So let's first find the equation of the normal at 2, 1. So that means it will have the same point, but the gradient will be minus the reciprocal. So my y minus y1 is equal to minus 2. The reason why this is minus 2 because the gradient of AB was half. So minus 1 by half will give you negative 2 and x minus 2. So y minus 1 is equals to minus 2x plus 4. So y is equals to minus 2x plus 5. Coordinate of the point where normal meets the line AB. So now I'm looking to find the point where the normal and the line AB will meet. I need the coordinate for the point of intersection. So that means the equation of the normal, which is minus 2x plus 5, must be equal to the equation of the line AB, half x minus half. Simplifying this, we get, if I multiply 2 with this equation, I get minus 4x plus 10, and this will become x minus 1. So minus 4x minus x is equal to minus 1 minus 10. So that will give us minus 5x equals to negative 11. So x is 2.2. Now let's find the y coordinate of this point of intersection. So y is equals to half of 2.2 minus half. And I'm using the equation of the line AB to find the y coordinate. So that gives us y is 0.6. So the required distance can be found with the help of these two coordinates. So that will be x2 minus x1 whole square plus y2 minus y1 whole square, and it should be square rooted. So that will give us square root of 0.2, or we can say square root of 5 over 5, which is 0.45. And that will be all for now. I will see you in the next video.